Okay, today we're talking about solving square root and other radical equations. So remember, a radical equation is an equation that has a variable in a radicand. Remember, the radicand is the part underneath the radical. Okay, or a variable with a rational exponent. So we just spent the first part of the chapter talking about these things. Rational exponent would be an example, x to the 1/2. Okay, we have two steps, main steps that you want to remember when you're solving these equations. First, you want to isolate the radical. Then you want to raise each side to the power suggested by the index. Okay, we'll do lots of examples so you'll understand what that means if you don't already. Remember, when you do this, you need to check your answers. If any part of your index, that is sometimes that power, when you're talking about rational exponents, is even. Okay, so let's go work some problems. First off, we have what is the solution of the square root of 4x plus 1 minus 5 equal to 0. So the first thing we want to do is isolate that radical. So that means I'm going to move the 5 to the other side by adding 5 to both sides of my equation. So that gives me 4x plus 1 equals 5. Okay, now raise each side to the power suggested by the index. Y'all already know this because you're used to square root, but think about the fact that this index is a 2. That's why we're raising it to the second power, because whatever that index is, that's the power that we're going to raise it to. So when we square both sides, of course, we've talked about most importantly that the square root of x, okay, quantity squared, same thing as the square root of x squared is equal to x. So they cancel each other out, leaving us here with 4x plus 1 equals 25. Then we're going to subtract 1 from each side. So that gives us 4x equal to 24. And then, of course, we divide by 4, so x equals 6. And before we box that, we're going to go check it. So let's go over here and check our answer. So we have the square root of 4 times 6 plus 1 minus 5. Does that equal 0? 24 plus 1 is 25. 5 minus 5 is 0. So we're good to go. So that means our answer is x equals 6. Okay? Now, as I said, if any part of your index is even, I'm just reiterating it. If either m or n in a rational exponent is even, then your answer is going to be the absolute value of x when you raise it to that power. Okay, and these are ones having rational exponents and sometimes it's not as obvious without your radical. Okay, regardless, we're still going to solve it the same way, and that is I'm going to divide both sides by 2 here because I want to isolate that expression. So that's going to give me x plus 3 to the 2/3 power equal to 8 divided by 2, which is 4. Okay, now what power am I going to raise it to? All right, as you see up here, we're raising it to the reciprocal because when you multiply a number by its reciprocal, then we get 1. So this is going to give us x plus 3 equals 4. Oh, wait, I was going to write up here. That's 4 to the 3/2. So that's 4 to the 3/2. Now, we just said, does any part of my power, m or n, is it an even number? Yes, it is. So I need to put absolute value signs here. So I now have an equation that says the absolute value of x plus 3 equals 4 to the 3/2. That means that's the square root of 4. Okay, it's the square root of 4 raised to the 3rd power. So hopefully you can see that's 2 to the 3rd, which is 8. Okay? And remembering way back to chapter 2, if to get rid of these absolute values, that means that x plus 3 equals plus or minus 8. Okay? And then to solve that, I'm going to subtract 3. So x equals negative 3 plus or minus 8. And we can't leave it like that. We got to simplify it. So that's x equals negative 3 plus 8 or negative 3 minus 8. So what's my final answer? Negative 3 plus 8 is 5, and negative 3 minus 8 is negative 11. Okay, let's go check. Alright, so I want to check 5, so that you always check it into the original equation. 2 times x plus 3 raised to the 2/3, does that equal to 8? So I put a question mark showing that we're checking it. Okay, I'm sorry, I'm supposed to put in a, not x, y'all, what am I supposed to put in? A 5. Okay, so that is 2 times 8 to the 2/3. Okay, does that equal 8? So that says the cube root of 8. The cube root of 8 is 2. 2 squared is 4. So 2 times 4, does that equal 8? And yes, it does. So that one works. On the second one, let's go with 2 times negative 11 plus, not, ah, negative 11 plus 3 raised to the 2/3. Does that equal 8? Okay, that's 2 to the negative 8 raised to the 2/3. And negative 8, the cube root of negative 8 is negative 2. And when we square that, we get 4 because that negative, whenever you square a negative, you get a positive number. So 2 times 4, does that equal 8? Yes, it does. So we know that our answer is x equals 5 or negative 11. Okay, let's go to the next example. Oh, notice what we have here. We have another x in here, but you always want to isolate that radical. So I'm going to move that 3 over, which means I'm going to subtract 3 from both sides. So I'm going to have the square root of 5 minus 1 equals x minus 3. Okay, again, that root is 2, so I'm raising both sides to the second power. This one goes away, leaving me with 5x minus 1. Got to remember how to square that binomial. That's a minus b quantity squared. A squared minus 2ab plus b squared. In case you didn't remember. So that's going to give us x squared minus 6x plus 9. Alright, this time we have a quadratic equation, and we solve quadratics by bringing everything to the same side. So that's going to give us 0 equals x squared. Subtract 5x is going to give me minus 11x. Add 1 is going to give me plus 10. And now we need to factor, and it does. So we have x minus 10, x minus 1. And that leaves me with, setting each factor to 0, x equals 10 or 1. So we need to go check those. Alright, again, checking the original equation. So I have 5 times 10 minus 1, the square root of that, plus 3. Does that equal 10? Okay, 5 times 10 is 50. 50 minus 1 is 49. Square root of 49 is 7. Does 7 plus 3 equal 10? Yes, it does. So we're good with that. And then I have the square root of 5 times 1 minus 1 plus 3. Does that equal 1? 5 minus 1 is 4. Square root of 4 is 2. Does 2 plus 3 equal 1? No, it does not. Okay, so 1 is not one of our solutions. and we have only x equal to 10. Okay? To refresh your memory, if you had any trouble remembering about factoring, the ways that we have to solve quadratics, okay? We have factoring is one, okay? You have the quadratic formula. You have graphing. Put it on your graphing calculator. Find out where it crosses the x-axis. And 4, completing the square. All methods to solve quadratics. Doesn't really matter which one you use, but you need to be familiar and efficient with one of them to solve your quadratic equations. Okay, last example. This one actually involves two radicals. So when you do this, you want to isolate the, let's say, more complicated radical first. You're going to end up having to square it twice. That's okay. So which one is the more complicated? The one that has more than just an x term with it. Okay? But again, my index is a 2. So actually, before I do that, I need to move my radical over. So that's going to give me the square root of 5x plus 4 equals square root of x plus 4. Okay? My radicals, my index on both of these is a 2. So I'm going to raise it to the second power. And that gives me 5x plus 4 equals, this squared is x. Then I multiply them together and multiply by 2. That gives me 8 square roots of x. And then I square the last term, which is 16. Okay, so if you notice, we still have a radical in there. So I'm going to isolate that radical. So I'm going to take the x over. 5x minus x is 4x. I'm going to take the 16 over. 4 minus 16 is negative 12. And that's going to equal 8 times the square root of x. Now, if 8 went into both of these, you could simplify it. I could do it by, like, let's go ahead and do it. We'll do it by 4. Okay? If I divide everything by 4 here, because I know 4 goes into each of these, I'm just making my numbers smaller. So that gives me x minus 3 equals 2 square roots of x. Okay? That's as far as I want to isolate it because I don't want fractions. But at this point, to move forward, I'm going to, again, square it. Okay, there's my binomial squared, so I square the first term, multiply them together, times 2, so that's minus 6x, and then I square the last term, and then I have to square the 2, and then square the square root of x. So that's what I get. We are back to another quadratic, so we're going to bring the 4x over, which is going to be x squared minus 10x plus 9. And hopefully you recognize that this will factor x minus 9, x minus 1. So that leaves me with uh, x equals 9 or 1. So we got to go check those again into our original equation. So let's go with, we'll check the 9. So I have the square root of 5 times 9 plus 4 minus the square root of 9. Does that equal 4? Well, 5 times 9 is 45, plus 4 is 49. Square root of 49 is 7. Square root of 9 is 3. Does that 7 minus 3 equal 4? Yes, it does. Okay, let's check 1. So we have 5 times 1 plus 4 minus the square root of 1. Does that equal 4? 5 plus 4 is 9. Square root of 9 is 3. Square root of 1 is 1. Does 3 minus 1 equal 4? No, it does not. So we cross that one out, and our answer is just x plus 9. So that is all we have for solving square roots and other radical equations.